today's lesson is on the quadratic formula. So the first thing we're going to do is we're going to derive the quadratic formula. So this is not just some magic formula that always works. It works because of completing the square. So we're going to start with a standard form quadratic. So meaning we're going to have ax squared plus bx plus c equals 0. And we're going to complete the square in order to derive the quadratic formula. So the first step we would do when completing the square is we would either divide by a or move the c term first, our choice. So since I'm doing this problem, I'm going to start by dividing everything by a. And that would give me x squared plus b divided by a x plus c over a equals 0 divided by a, which is just 0. Okay, so all I've done is divide the constants by a. So the next step, I would move the c over a to the other side. So x squared plus b over a x equals negative c over a. So I'm subtracting it to the other side of the equation. So now at this point is where I would complete the square. So remember, completing the square comes from halving the middle term. So in this case, the ba term. In order to half this, we would have to multiply it by 1/2. So when we multiply this by 1/2, so we still have our x squared plus b over ax, we would end up with b over 2ax. So that is what we're adding to this side. Okay, and again, this simply comes from halving. So if you were to kind of see it over here, instead of doing b over a divided by 2, we would do b over a times 1/2. And so that would give us that b over 2a. Okay, so whenever we're dividing a fraction, we just multiply by 1/2. We're dividing it by 2. And then we do the same thing to the other side. So on the other side, although for some reason I wrote an x here that I should not have written, so my mistake. So this side should have been b over 2a squared. So remember, we half the middle term and then we square it. So on the right side, we would add that same amount. So I'm going to go ahead and square it. I'm going to put plus b squared over 4a squared. So you have to square the b, square the 2, and square the a. So now on the left side, this would factor into x plus b over 2a squared. Now remember, this is the reason I leave b over 2a not squared. I would just put it as a power of 2 so that it makes factoring easy. On the right side, we need to get common denominators. So when we look at a and 4a squared, their common denominator would be 4a squared. Okay, that'd be their least common denominator. So we had to take and multiply a by a 4 and an a, which means we have to do the same to the top. So negative c times 4a is negative 4ac. Okay, so again, we simply multiplied a by 4a to get 4a squared. We multiply the top the same way. Now, on the second fraction, we didn't have to multiply it by anything other than 1, so that just stays as b squared. So we're going to go ahead and put this together. So x plus b over 2a squared equals, well, since they now have the same denominators, we can add. So negative 4ac plus b squared, I'm going to put it in b squared minus 4ac, because that's starting to look like something that we are familiar with. And then it's all over 4a squared. So I got it into one single fraction. So now the next step would be to solve for x. So we are going to take the square root of both sides. So x plus b over 2a squared. And we're going to take the square root of b squared minus 4ac all over 4a squared. Okay. Now remember, when we take the square root of an x being squared, that creates the absolute value. So the absolute value of x plus b over 2a equals, and we're going to try to clean up this right side as much as we can. Now the numerator is a sum or difference. We cannot simplify this as it is not a perfect square. Okay, but 4a squared is a perfect square, and so the square root of 4 is 2. The square root of a squared is a. So we have this 4a here. And now, remember, a is an actual number here. Okay, so we're just using a as a placeholder for a real number. So now we have to create our two equations. So I'm going to do that up here in this space since I have a little more room. So we're going to have x plus b over 2a equals the square root of b squared minus 4ac all over 2a. And we would have the opposite of x plus b over 2a equals the square root of b squared minus 4ac all over 2a. So we're going to solve these separately. So the first one we would simply subtract the b over 2a, so that would be negative b over 2a plus the square root of b squared minus 4ac all over 2a. Okay, and if we were to put this together under one single fraction, they have the same denominator. We would have negative b plus the square root of b squared minus 4ac all over 2a. And then on the other side here, I would go ahead and multiply both sides by negative. So x plus b over 2a equals negative square root of b squared minus 4ac all over 2a. And then subtract the b over 2a. So negative b over 2a minus the square root of b squared minus 4ac all over 2a. And again, we can put this under one common fraction if we want. So 2a is the denominator, negative b minus the square root of b squared minus 4ac. And then we would most likely put these together so that we would end up with x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, which is our quadratic formula. Yay. So this is where the quadratic formula comes from. And you need to be able to derive it. So you need to be able to follow this same process and do this. If all I gave you was ax squared plus bx plus c equals 0, you would need to be able to derive this all the way down to the quadratic formula. So one thing I do want to show you, which I think is really neat, is notice this negative b over 2a here. That is the vertex. And then this piece right here is actually just the distance formula from the vertex. So the quadratic formula is simply the vertex and then every point's distance from the vertex. So that's kind of a cool little tidbit. Alright, so now we're going to solve some equations using the quadratic formula. So starting with number 1 here, and I'm going to do one with you to get together so you know what my expectations are, and I'm going to have you guys try some, okay? So starting with number 1, we're going to have x squared plus x equals 6. So very first thing you should do when deriving the quadratic formula, or sorry, when solving for using the quadratic formula, is to get everything equal to 0. So it needs to be in standard form. So we would start by, of course, subtracting 6 so that this equals 0. Okay, and then at this point we are going to use our good old quadratic formula. So just kind of a little reminder, just in case you've forgotten. In this case, we need to know a, b, and c. The a is understood to be 1, it's in front of the x squared. The b is understood to be 1 because it's in front of the x, and the constant is negative 6. So we are going to be filling in this quadratic formula right here with those values, those a, b, and c values. So in this problem, we'd have x equals negative, and then our b is 1, plus or minus the square root of 1 squared, minus 4 times a, which is 1, times c, which is negative 6, all divided by 2 times a, which is 1. Okay, so I should be seeing kind of what you're plugging in. Now, if this was a word problem or a situation where it was okay to round, then you would be able to plug that entire thing in the calculator and calculate it. However, when it's not, we need to give exact values. And I will always expect exact radical form unless noted otherwise or unless it is a context problem that deserves a context solution. Okay, so otherwise we are going to start by doing what's underneath the radical. So we'd have 1 plus 24, which should be 25. So we should have negative 1 plus or minus the square root of 25. I should always be able to see that value underneath the radical, which is called a discriminant. So just a reminder of the discriminant, I should always see what that value is. And then divided by 2. Well, good news is 25 is a perfect square. So this is one that is fairly easy to do by hand. So that's going to be x negative 1 plus or minus 5 over 2. And then just a reminder, this is negative 1 plus 5 over 2. And this is negative 1 minus 5 over 2. I should have two nice answers here. So that's going to give me 4 over 2, which is 2, negative 6 over 2, which is negative 3. So these are quite nice answers. In fact, this problem would have probably been better served by factoring, simply because the answers are so nice. All right, so I want you to try number 2, please. So here is number 2. It's 4x squared plus 8 equals negative 2x. So go ahead and pause the video, and when you're ready, turn it back on. Alright, hopefully you are ready to see the answer. So when you plugged this in, you should have got a discriminant of negative 124. So again, I should be able to see this value in your work, okay? Now, negative 124 is not a perfect square, and more importantly, it is going to create an imaginary number. So you should have ended up with negative 2 plus or minus 2i square root of 31 over 8. Now, here is where you're needing to be very careful. This can be simplified further. Okay, this negative 2, this positive 2, and this 8 all have a common factor, which means you need to divide all three of them by 2. So your final answer should be x equals negative 1 plus or minus I square root of 31 over 4. So if you got this one correct, give me a little smiley face in the bottom corner. If you got it wrong, fix it, and maybe do like a different face. You can do a straight face or sad face or whatever you want to do, but give me a little face in the bottom so I know how you did, okay? All right, go ahead and try number 3 then. So number 3, actually we'll do number 3 partially together. So 1.2x equals 0.2x squared plus 0.6. Now, of course, the first thing to do is get this into standard form. So this would be 0 equals 0.2x squared minus 1.2x plus 0.6. Okay, so notice I did simply just subtract the 1.2x over. You could have subtracted the 0.2x squared and the constant over. That would have been fine. It's your choice. Now, one thing I will note here is that because this is a skill problem and I do want an exact answer, meaning a simplified radical if necessary, decimals are not very helpful in that case. So it would be in your best interest to multiply everything by 10 in order to create a better equation to work with, to have those integer values. So if we multiply everything by 10, we would have 2x squared minus 12x plus 6. So at this point, I want you to go ahead and solve this for me, and when you're ready, turn the video back on. Okay, so you should have got a discriminant of 96. At that point, 96 does simplify down to 4 square root of 6. And then again, you have to be careful to divide. Okay, it's like this kind of little triforce looking thing. So we do 12 divided by 4 is 3, 4 divided by 4 is 1. And notice I'm not messing with the radical, only the coefficient. Because this is really 12 over 4, and then 4 squared is 6 over 4. So I'm going to write that just so you can see it in case you need to. So this is really 12 over 4 plus 4 squared is 6 over 4. And that's why you are simplifying those 3 pieces, because you are basically simplifying 2 fractions. So you should have gotten 3 plus or minus the square root of 6. So again, if you got that right, put a little smiley face in the bottom corner. If you got it incorrect, then maybe a frowny face or a sad face or something of that nature, and then make sure you fix it. Okay? So now on to the back. So that's using the quadratic formula, which I am fairly sure that you will find that a very useful tool. So the discriminant, which we've been kind of talking about as we go, is simply that value underneath the radical. So it's that b squared minus 4ac. And the discriminant is very useful because it will reveal the types and numbers of solutions without actually having to compute the answer. So sometimes it's not about getting the answer, it's about knowing what kind of answers we're going to get. So you will get 2 real solutions if your discriminant is positive. So if b squared minus 4ac is bigger than 0, so any positive number, you can expect 2 real solutions or 2 real zeros. Now, some other information that's useful is that if the discriminant is a perfect square, then you can expect your solutions to be rational, which means it will most likely factor. If they're not, then they are probably irrational, which means they would not factor. Okay? Now, if you only want real solution, and so you can also see in a graph, doesn't matter the opening, it just matters where it crosses the x-axis. So if it crosses the x-axis twice, then you know you have 2 real zeros. Okay? Now, if you have 1 real solution, that means your discriminant has to equal 0. Okay, that means you are actually given the vertex. Okay, and think back to the quadratic formula. If this piece equals 0, notice you just have negative b over 2a. All you have is the vertex part of the formula. Okay, so that means you actually have the vertex. And that's only going to create 1 real solution, or 1 real 0. Now, if the discriminant is negative, so if it is less than 0, then you can expect 2 complex solutions. Okay, so notice on this graph, it does not cross the x-axis. It still has zeros. It's just that the zeros are not real. The zeros are complex. And what you can expect is that you're going to have complex conjugates, which means it's going to be that plus and minus. So like you might have 2 plus the square root of 3 and 2 minus the square root of 3. Complex solutions will always come in pairs, and they will come in conjugates. Okay? So down here on 4 and 5, we are going to determine the number and type of solutions just based on the discriminant. So for number 4, we're going to have 2x squared plus 5x minus 3 equals negative 6. So again, the very first thing you should be doing is putting this in standard form. So that would give us 2x squared plus 5x. If we would add the 6 over, that's now positive 3. Okay, negative 3 plus 6 is positive 3. So all we are going to calculate is our discriminant, b squared minus 4ac. We only want to know the types of solutions. Okay? So when we fill this in, we would have 5 squared minus 4 times 2 times 3. And this is your mathematical proof. So I don't mind if you put that whole thing in the calculator and get the value, but I do need to see what you've plugged in. So 5 squared minus 4 times 2 times 3. So what do we have? 25 minus 24, so 1. I believe it's 1. So since the discriminant is 1, it's positive. This means that we have 2 real solutions. And even better, we have 2 real solutions that are rational, because 1 is a perfect square. So we have 2 real solutions that are both rational. Okay, which means this would have actually factored for us. We could have factored this expression very easily. Okay, so I want you guys to try number 5. So number 5's equation is 4x squared plus 6 equals x minus 1. So go ahead and pause the video. When you're ready, turn it back on. All right, again, hopefully you are prepared for the answer. So you should have gotten the discriminant to be negative 111, provided I have not made any mathematical errors. Which means, since it is negative, you would have 2 complex solutions. So again, you got it right, little smiley face in the corner, just so I know that, hey, did pretty good on this one. All right, and if you have any questions, make sure you're writing those down as we go, okay? So, last thing we're going to do is a couple of context problems. So, we talked about this formula a little bit a few days ago, but in case you've forgotten, we do have our vertical motion formula. So this is the vertical motion model. And what it looks like is h of t equals negative 16t squared plus v sub 0 times t plus h sub 0. Now remember, this is if you are in feet on Earth. If we were not on Earth, or if we were not in feet, that negative 16 would be a different value. Okay, so this is assuming we're in feet and we're on planet Earth. So a couple of things to remember. V sub 0 is the initial vertical velocity. Okay, and it can be positive or negative, just depending on, or it could be 0. And what we saw before is when it was 0. When there was no vertical velocity, we were simply letting gravity take its toll. And then, of course, h sub 0 is the initial height. These are 2 things that must be filled in before starting. Okay? So if we look at number 6, it says a juggler tosses a ball into the air. The ball leaves the juggler's hand 4 feet above the ground and has an initial vertical velocity of 40 feet per second. The juggler catches the ball when it falls back to a height of 3 feet. How long is the ball in the air? Alright, so we're going to start with our formula, h of t. And the 2 things that we need to fill in is our vertical velocity, which comes from right here where it says the initial vertical velocity. They're pretty good about that in the equation of just telling you what you need. Now, it is a positive vertical velocity just because of how I know a juggler works. So a juggler is going to throw the ball up in the air. It's not throwing it down. If he was forcing it downward, then you could have a negative vertical velocity. So since he is throwing it up, this is going to be plus 40t. And then we're going to have our initial height, which in this case, it's leaving his hand at 4 feet above the ground, which makes that a positive 4. We want to know how long the ball is in the air, so what we need to now know is what's our ending height. Well, in this case, our ending height is 3 feet. So we have a height of 3 feet of where it's ending. So that's going to be this height right here. This 3 equals, and then negative 16t squared plus 40t plus 4. Now, graphically, you could solve this by setting y1, let y1 be 3 and y2 be this other quadratic equation and see where they intersect. But algebraically, if we want the exact answer and we want to show some mathematical reasoning, we would use probably the quadratic formula on these just because it's a little quicker. So first things first, get it equal to 0. So negative 16t squared plus 40t plus 1. Oops, sorry. And at this point, just plugging it into the formula. So since we're using t's instead of x's, I'm going to say t equals, so b is negative 40. Then we would have 40 squared minus 4 times negative 16 times 1 over 2 times negative 16, which would give us negative 40 plus or minus. Now that discriminant is rather large. If you type it in, I believe it is 1,856. I'm going to type it in here just so you guys can verify for me in case I do something crazy. So 40 squared minus 4 times negative 16 times 1. So 1664. Oh, I got a completely different answer. So this is why we verify. Let's try this again. So 1664. Again, please make sure that I have done that correctly, as mistakes will happen. Okay, and that should be over negative 32. Now, I'm not sure that that's a perfect square. It might be. So let's see if 1664 is a perfect square. It is not. Okay, so at this point, we're in a context. It makes sense to round. So in fact, instead of doing this piecemeal and possibly making a mistake, I'm actually going to put this entire fraction in. However, I'm going to have to do it twice. Okay, so I'm going to show you how I would do this. And again, I would only do this in times that I don't want an exact answer. This makes sense to have a decimal. Okay, so I'm going to do alpha F1, select the fraction key, and then I'm literally going to type in that entire thing. So negative 40 plus the square root of 1664 over negative 32. And I will tell you, you could have done that right here with this original problem, knowing that we were going to a decimal most likely. Again, it just depends on what we're asked to do. If it's a skill problem, complex, I need an exact answer where I need a simplified radical, you would not do this. But this is a word problem. So we end up with negative 0.02 approximately. Negative 0.02. So you're probably thinking, not a good answer. And you'd be right. And instead of having to type all of that in again, there's two ways you can do it. You can go up and you can grab it by highlighting and hitting enter, and then you could move over and change the plus to a minus. The other way is you could actually just hit second enter. Now it's going to pull up the one I just put in. So notice it pulled up the one I just put in. But it will pull up the last thing you've typed in if you do it that way. But either way, we get 2.52. So about 2.52. So this negative answer is time. It doesn't make sense. Therefore, we would say, how long is the ball in the air? The ball is in the air 2.52 seconds. Approximately. So I like to put the little approximately sign in there just to make sure somebody knows that, this isn't about. This isn't exact. This isn't about. You could put say about. But either way. I would not count it wrong if you don't put the approximate sign. It's just something I do. Okay? Alright, go ahead and try number 7, and when you're ready, turn the video back on. Alright guys, so when you set this up, hopefully you started by setting it equal to 0 as it is hitting the ground. Now one thing you're going to notice is I did not eliminate the decimals here. And again, this is because this is a context problem. So I knew my answer was going to be probably an approximation. So if it wasn't exact, I was going to a decimal anyway. So I went ahead and left it in decimal form. That doesn't mean you can't get rid of the decimals by multiplying by 10. Just know that you will be working with bigger numbers. Some people prefer to work with bigger numbers instead of decimals. Some people would rather work with decimals than bigger numbers. It's your call. Okay, so I would not count it wrong either way. Just make sure that you are following through with your numbers, okay? So now, again, notice all I did was plug this entire value in. And again, I'm going to show you what's in my calculator just in case I've made a mistake and you can catch me on it. But I got about negative 0.09 and 5.60, And again, this negative answer would get tossed as it is not logical in the context, which means the balloon will hit the ground in about 5.60 seconds. And you will notice I am leaving it as 5.60. If the directions or the problem does not tell me what to round to, typically I prefer that you round to at least 2 decimals just to keep it as precise as possible. So that's just kind of a rule of thumb for me, if you will just make sure in 2 decimal places at least, unless stated otherwise. Now if it tells you to round to the nearest tenth or the nearest hundredth, well then you do what the directions say, okay? So again, if you got this one right, a nice little smiley face in the bottom. If you got it wrong, maybe a frowny face or a straight face, whatever you feel like. Make sure you fix it. And then that is it on notes. So at this point, you will get your you will start your homework, which is under Canvas. So it should be 2.6 practice A. Okay, so go ahead and start that, and you're done.